Okay, so the basic idea for these questions is we're going to rewrite the more complicated side, the right-hand side, or the left-hand side, and when we simplify it, it's going to turn into one of these five, and so then we figure out, which one of these goes with which one of those, essentially. A good strategy, and then what we get to use to do that, oops, no, don't turn off the Wi-Fi, there we go, is these identities. So we have tangent, cotangent, reciprocal, and Pythagorean. So those are the ones that we're using to try to simplify these. Let's leave that over there so we can see our identities. A good strategy is to rewrite, when we're given kind of mixed things, try rewriting it all in terms of sine and cosine, and sometimes that will kind of help you see where to go. So let me make that a little smaller. There we go. So for cosecant, we can rewrite that one as 1 over sine. So let's do that. And then here, since I have subtraction, if it was addition, subtraction, I would try to get a common denominator and then combine those. Just writing it as a single expression is probably going to be helpful when I look at the form of the answers. None of these answers have addition or subtraction in them, so that tells me I'm probably going to want to simplify that. So we'll think of that as sine over 1. And then our common denominator would be sine theta. So we'll do a sine theta right here. Oops. So that will give us 1 over sine theta minus sine theta squared, because we're going sine theta times sine theta over sine theta. Now those are over a common denominator, so I can rewrite this as 1 minus sine squared theta over sine theta. And whenever I see that sine squared or cosine squared, that makes me think of the Pythagorean identities over here. So if I subtracted sine squared theta over to this side of the equation, I'd be left with cosine squared theta equals 1 minus sine theta, which is this right here. So that means I can replace this with cosine squared theta. Let me write out what I just said. And so I'm subtracting this, thetas. So I'm subtracting sine squared theta over to this side, so I get cosine squared theta equals 1 minus sine squared theta. So replacing this with cosine squared. So then cosine squared theta, I'm going to think of that as cosine theta times cosine theta. And you certainly don't have to write out that step, but it helps for me to show you so that I can show you that we have cosine theta over sine theta times an extra cosine theta. And if we go up here, cosine theta over sine theta, this piece of it is cotangent. So then I can write this as cosine theta times cotangent theta. And about there, that makes me want to now go, okay, I bet that's one of my choices. So cotangent cosine, so it's right here, so this one would be D. And then you do the same with these next 4 things. Let me do a couple of them, and then I'll leave you the other couple. This doesn't always work, but if you notice for the second, third, and fourth ones, this tangent theta plus cotangent theta, there it is again, tangent theta plus cotangent theta, and there it is again, tangent theta plus cotangent theta. So once I figure out what that is, I can use that to answer all 3 of these. So I'm going to start with the most simplified version of it, which is the tangent theta, cotangent theta, and figure out what this reduces to, and then I can plug that into those other 2 equations and not duplicate that work. That doesn't always work, but since this one has this kind of repeated expression in it, I might as well take advantage of that. So tangent theta plus cotangent theta. So tangent theta from our identities here is sine over cosine, and cotangent is the reciprocal cosine over sine. So let's change those to sine and cosine. And then that's going to be plus cosine over sine. So again, none of our right-hand sides have any addition in them, so that makes me think I probably need to add these. And so we'll get a common denominator. This one's cosine, this one's sine, so the common denominator would be cosine times sine. So it's the same idea as if I have 1/2 plus 1/3. This side needs the 3's, and this side needs the 2's to bring these both up to a common denominator of 6. So here, this side needs the cosine, and this side needs sine. So up top, that's going to give us sine theta times sine theta, so that is sine squared theta. Over here, cosine theta times cosine theta is cosine squared theta, and that's all over sine theta cos theta. And then here we have these squareds again, so that's our Pythagorean identity, sine squared plus cosine squared equals 1 over sine theta cos theta. That is not one of our choices, but sine theta and cos theta, or 1 over those, can actually be written as secant is 1 over cosine, and cosecant, there it is, cosecant is 1 over sine. So this is like 1 over sine theta times 1 over cosine theta. And so sine theta again, 1 over sine theta is cosecant. Oops, and then I start writing cosine, cosecant. And cosine is secant back on that sheet. And there it is, so secant theta, cosecant theta. That's what we got for this one. So that means this one would be cosecant theta. This one is C. So knowing this one makes these next two a lot easier. I'll just show with this, with A here, for example. So sine theta times tangent theta, cotangent theta, this is going to reduce to the same thing. I think it would be probably more useful. I can substitute this in at any of these places. I think so. We'd have sine theta on the outside. On the inside, I think I'm going to grab it right here because it looks like that's actually going to cancel pretty well for me at that stage. We would still, for this middle bit, we would still have to do all that same work, but since we've already done it, I'm going to skip down to this step right here and say when I have tangent theta, cotangent theta, I can replace that with 1 over sine theta, cosine theta. Had I not, I just would have done this exact same work. And the reason I picked this spot is because it's pretty simplified, but still in terms of sine and cosine. And because of this one out front here, what that does is it helps me see that I'm going to be able to cancel. So that seemed like the spot to make that substitution. And that leaves me 1 over cosine theta. And again, 1 over cosine theta is secant theta. And so that one should be A. And then you can do the same thing with C, and it'll just end up a cosine on the outside. This one is pretty much the same as that first one that I did. Oh, it does have one little trick to it though. Actually, let me go ahead and show that one because of that negative sign. So similar here, we would have cosecant or cosine theta minus secant theta. And so with our secant, that's 1 over cosine. So cosine theta minus 1 over cosine theta. And then like we did on the first one, we're going to want to get a common denominator here. So I'm going to go cos theta over cos theta. So that gets me cosine squared theta minus 1 over cos theta, because that's our denominator. So on this one, if we look at this identity, let me write it out over here. Sine squared theta plus cos squared theta equals 1. We have to be a little bit careful with our signs. So if I just brought cosine over, I would have 1 minus cosine squared theta, which isn't quite what I have here. So I want to make it so that this looks just like this piece. So what if I brought the minus 1 over, and that left nothing over there, so that would be equals 0. Now I have this piece that's right there, and so I'd have to subtract sine squared theta over to this side, and that would leave me exactly what I'm looking for, cosine squared theta minus 1 equals, and then when I subtract that, it'll be minus sine squared theta. So this will be minus sine squared theta over cosine theta, and then like we did before, we can think of that as minus sine theta times sine theta over cos theta, and then sine theta over cosine theta is right there, so that one's tangent, so it will be negative or minus sine theta times tangent theta. And that's how they got that negative sign. So you just have to be a little careful with that substitution and make sure that your signs are squared away. So that is the basic idea with these. These other ones are going to be pretty similar. Kind of a different chunk of math for those, but similar idea. You would be trying to, so these ones like are all addition or subtraction. So you're going to want to get a common denominator probably every single time, which is just going to be multiplying. This one needs this piece, numerator and denominator, and then this one needs this piece, numerator and denominator. And then you're grinding out that addition or subtraction and reduce to one of those. Yeah, and that is basically the rest of this assignment, is trying to reduce the left-hand side to look more like the right-hand side. So holler if you have follow-up questions. Again, I think I did a bunch of these examples in the notes of how you get these things to simplify. But yeah, do holler when you have follow-ups.